binary. That is yes or no, win or lose, 1 or 0. You do not use regression. Rather, you use what we call the logistic regression model, or the probabilistic regression model. So we use it when the dependent variable has 2 possible values. An example that you know could be what? Win or lose. Abigail Safo, give me one example. Anything that has only 2 outcomes, die or you live. Ruth Dapo, give me another example.
Prof, please, I'm here.
Yes, but you never gave me an example. Give me one example.
Okay, so you said die or leave.
Yes, that's my example, not your example. So what's your example?
Okay, good or bad?
Good or bad? Ruth Dapo, another example.
Whether you are in or out.
You are, but in or out, don't I have in or out? Okay, win or lose. Okay, good. So you have it. So common example, will a customer buy? Yes, no. Is an email spam? Spam, not spam. Will a patient recover? Recover, not recover. Right? Will a person be high? High, not high. Will they increase our salary? Yes. No. So these are some of the things. Are we satisfied at our workplace? Yes. No. Satisfied, not satisfied. That kind of thing. So why not a linear regression model? Whenever we use a linear regression, we say that our predictor is a continuous number. The predictor is a continuous number. So, for example, we are looking at salary, right? Against as the dependent variable. Then we are going to look at a linear regression model. But whenever you have a categorical model, then you use a logistic regression model. Whatever holds for the logistic regression also holds for the probit. The only difference between the probit and logit is with respect to the curves. The curves have significant meaning if you want to know. So a logistic function, or what we call the sigmoid, right, where we try to convert between 0 and 1, has this formula. This is how it is written. And before you get here, it's a derivation. But this is a simplified version. So please take note of it. Again, why is this thing not moving? Again, our basic question is, oops, so our output is from 0 to 1. You cannot have more than 1. You cannot have less than 0. Because of that, we always set what we call the threshold of 0.5. So if the probability is greater than 0.5, we say it is yes. If it is less than 0.5, we say it is no, especially if you want to turn a continuous variable to a probabilistic variable. That is why usually I like to have age as a continuous variable so that when I want to change it into a continuous variable and say I want to find out old against young, I can easily convert it. Even if I want to put it into categories. But if you take the age as a categorical variable, you can change it to continuous. Now, ladies and gentlemen, whenever you get the final result, we interpret the results as odds and log odds. For the gentlemen who like to do a lot of gambling or who like to invest, now they say that they are not called, they don't gamble, they invest. You hear of the odds. Those who do a lot of casino work, you hear of the odds. What is the odds? The odds is the chance of an event happening or not happening. The chance of, if you're a football fan, maybe the chance of Chelsea winning or not winning, or the chance of Manchester United winning or not winning, or the chance of Arsenal winning and not winning. If you are a horse racing person, the chance of one of my favorite horses is Holy Cardau. It's the name of a horse. That is when we used to go for at the Polo Club to watch horse racing. It's nice if you are watching. So Holy Cardau, winning, not winning. When you find the natural law, then we say log odds. And when I start so we will look at it and then I'll give you the interpretation so that you don't interpret it as if you are interpreting a normal linear regression. Now, the logistic regression predicts what we call the log odds. Please keep this at the back of your mind. What else again? Who has a different explanation to what I have? I mean, or you have again, you hear of this all the time. The odds of those of you who go to the mall and have ever been to the casino before, they always play the odds, right? And those of you like watching, how do you call it? Movies, which has this cards and the rest, you hear of the odds. So please put that at the back of the mind. We've talked about this, the threshold is this, the odds, the chance, the logistic, talk about this. And this is what the output means. Again, the logistic equation is given by this. Take your time and look at it. Just, if you are confused, don't worry. Just smile at it and you'll be fine. If you frown your face, you might not enjoy it. So this is how it is written. Remember, we have not derived the equation yet. So we are just looking at it and smiling at it. Where P is the probability of an event happening against the probability of the event not happening. Now, X is a predictor variable like age, salary, etc., etc. The B are the coefficients, or what we call what's the model length. Any question before I move on? What about the predictor variable in the model fit? The predictor variable can be of any nature. It can be numeric. When I say the predictor variable, I'm just looking at the x's, right? Remember, the predictor variable is here. So please keep the terminology in your mind. The predictor variables are my x's, so please take a look at it. So the predictor variable can be numeric or it can be continuous. Now, that's numeric, continuous, or it can be categorical. So look at this. Give me an example of a predictor variable that is continuous. Kennedy, Mr. Kennedy.
Yes, sir.
An example of a predictor variable that is numeric. Then, Madam Frida, you
The
continue with age, but I have age over there. Any other? Madam Frida, give me an example that can be categorical.
Prof, please, can we say height?
Yes, but you are not supposed to. You have said your part of the bargain. So our height, yes. Madam Frida. Madam Mimi.
Gender. Gender.
But gender is already there. Anything apart from what I have projected. Yes, Emanuela, Ama.
Marital status.
Status. Okay. So those I called. It means I can give you -1 each. Yes, Miriam.
Education.
Education. Whether you're educated or not educated. Then we have another thing we call the model fit. And the model fit is what we call the baseline that separates the two classes. Now, we use the model fit when we are looking at the maximum likelihood estimation. I won't go much into details here, but I will explain that what we do in the, excuse me, let me just charge my router before it's too late. What we do, okay, what we do is basically we use what we call the maximum likelihood estimation whenever we are doing a logistic regression model. Please pay attention here because we would always have to be held accountable one of these days. So the question is, what is the maximum likelihood estimation? What is the maximum likelihood estimation? Now, the keyword here is maximum. The second keyword is likelihood. The third keyword is what? Estimation. Now, therefore, what we say maximum is the highest, the likelihood, the probability of it occurring. Now, what we do in the whole maximum likelihood is we are trying to find an estimate that gives us the best in terms of the chances of an event happening. Now, so we are finding out what will give us the best in terms of an event which is likely to happen. And it is usually used when we are estimating probabilities. So please keep that at the back of your mind. I don't want to go into the calculation. There's a way of calculating it. You are not here to if you want to learn the calculation, see me in chambers, we will derive it. So how do we interpret the coefficients? And remember, we said we'll make this note very, very simple for you. So we have tried our best to break it down to the barest minimum. How do we interpret it? If you get a positive coefficient, let's assume that your dependent variable is a yes or no. A positive coefficient, you can say that you can interpret it as the higher value of the predictor increase. That also yes. Or the odds of getting a yes when a predictor increases. Then if you have a negative, we are saying that the odds of getting what? A decrease when a predictor variable increases. And remember that the exponential coefficients can turn our odds into odds ratios. All that I'm saying can be gone back here. You see this? E is indicating this is exponent. As much as possible, I want to avoid the mathematics. So that is what I am referring to, the circled one. That's why I'm saying that by the exponential coefficient can turn your odds into odds ratios. Unlike the other cases where we're doing the diagnostic test left, right, center, in evaluating the performance of a model, you have to check for model accuracy. You have to check for precision and recalls, which we will do. The F1 scores, the ROC curve, and the AUC curve. We would come and do all this when we are trying to evaluate the performance of any good model. What are the assumptions underlying a logistic regression? What are the advantages and what are the limitations? What are the assumptions? What are the advantages? What are the limitations? I must say that we have given you some of the assumptions, some of the advantages, and some of the limitations. Should you meet it somewhere, once I give you 3, I'll demand you add extra 3. If I give you 1, I'll demand you add extra 1. I'll be like the master who gave you the talent. So you invest it and get 1 in addition. Right. So, for example, the first assumption is independence of observation. The second one is linearity. We've explained this in previous slides. That's why we have just kept quiet. The third one is no multicollinearity. You have met the word multicollinearity again, ladies and gentlemen. So, The question is, what is multi-coloniality? Simon Opoku Jambibi, what is multi-coloniality? Edith Beda Aoku, what is multi-coloniality?
Hello, Doc. Please, I'll come back. I'm coming.
Okay, so you go and search and come. Bridget, what is multi-coloniality?
Yeah, Doc.
Yes.
Yeah, good afternoon. This is Simon.
Simon, yes.
Yes, in the simple terms, it can be when two predictors are somehow similar or familiar, similar. Maybe, for example, the years of schooling or let me say educational level. That's my understanding.
Okay, you have done well.
Thank you.
Eric Shremi, Mister, what is multi-coloniality? Okay, so let's move on. On that day, we will write. But this several times I made mention of multi-coloniality. So please take note of it. What is the advantage? Simple and easy to interpret when you have the results. Handles multiple predictors. It generates probability and odd ratios. What is the limitation? The limitation is that it is only works for binary outcomes. And it is very sensitive when you have an outlier. Eugene, what is an outlier? Madam Gloria Popo Okanse, what is an outlier? Priscilla Apia, Madam, please, what is an outlier?
Hello.
Yes, Madam.
When
Okay.
Hello.
Yes. Don't worry. Let's move on.
There.
Madam.
Please, you called my name.
Yes, I did.
I was a bit distracted, so
So what is an outlier, Madam Gloria Popo Okanse?
the
Or I should go and come.
can you say it's a data that is significantly different
Hmm.
from the other observations in the data set?
So at the master's level, if you write that, we are in for trouble.
Yes, sir.
So please refine your statement. Okay, Bridget, Odru, Trewa, the last person, what is an outlier? Okay. Yes,
Good afternoon.
good afternoon.
So, I would say that an outlier is data that is different from the usual observation or a significant. It varies from the normal data or a data point. That is what I would say.
Okay,
Yes.
thank you. Okay, thank you. So, yes, Emmanuel, your hand is up.
Yes, so I wanted to add that I remember when we were using the R Studio, we did the box plots. So usually in the box plots, you realize that most of the points are closer to each other, but with an outlier, you realize that it is either far away or lower than the spread of points in there.
Good. Your people have forgotten what a box plot is. And let's move on. At least I'm happy that you remember a box plot. Okay, thank you. So again, the data assumes linearity between predictor and the locus, which is not reasonable. So please keep the assumptions and keep the advantages in your mind. Again, let's go and look at the example. I am going to use the Altera data set. And in the Altera data set, I would ask you to read the data. I'll give you all the commands, right? I'll ask you to read the data. You have the data. Then we will change some of the variables into categorical, or we would want to make them categorical variable. So, ladies and gentlemen, let's go to our R to do the rest of the work. So that whatever we generate in R, we'll put it back into the, so I'll come back into the slides and then we'll interpret it. Because everything we've done, we will generate it. So that when I'm interpreting it, you won't say that the lecturer has gone to put something somewhere we don't understand and then that's stuff. So if you permit me, let me stop sharing now. And then let me share my R Studio. This messing me up. Just a minute. So good, let me start. So ladies and gentlemen, are you with me, please?
Let's go.
Okay, so if you can see my screen, please let me know. Good, so this is for today, logistic regression. Today is 2nd November 2025. So please, are you with me? The first thing you need to do is to read the data. Remember, I am using the Altera data. So I have read the data set. And if you remember, you don't even need to, if you have all the files, it makes it easier because we've ever read the Altera data. And this is where we read the Altera data. So it's just a matter of copy and come and paste if you want. I have already read it, but for the sake of this class, I'm going to put it here like this. Please, if you ask me where the data is, I don't know your question, so it will be difficult for me to run. Can I move on? So let's start. You read the Altera data, and then you load the library. Load this library called dplyr. Please, have you done so? Or I should give you a few minutes.
Yes, sir.
Sir,
Yes.
please, what are we loading?
That's awesome. You don't know how to read the data.
Sir, I've loaded the data, but you said we should copy something, so
No, I never said you should copy anything. I said first read the data point.
yes, please.
Let's hold on for me. Please, you have a class here.
No, we have a class.
No, it's good.
Apparently, I'm also going to restart from here. So let's move. So that, please, are we good to go? I can get a place. Please, are we good to go?
Yes, please, Prof.
Okay, so if you've read the data, you know that we've done all the diagnostic test and the rest. So I don't want to, we'll check the data and then we'll look at the dimension of this particular data. So I'm not going to worry my head about it. The next thing is for you to load the library required. And the library required is called dplyr. So I'm going to copy this for you so that we can move a bit faster. Let me copy it. I'm going to put it in the chat. And then off you go. Please, can you see it in the chat?
Yes, Prof.
Yes, so copy it. Okay. Can we move on, please?
Yes, please, Prof.
Yes, Prof.
Okay, so if we can, when you ran the command I gave you, did you encounter any challenge? Now, once you are done running the command, the other thing I want us to look at is, oops, is my mouse not moving? Okay, let me close this. Yes, please. Okay, so please give me a few minutes. And then yeah, just give me a few minutes. Yes, Betty, any question?
No, Prof.
Abigail, any question?
No, please.
Okay, good. So once we are done, all these independent variables. Against all these independent variables. So we run it, and we add, the only option you add is family. The family is telling you which type of family you are using. And
Hello, Prof.
usually, yeah, no, I'm guessing.
Sorry, I think Bridget was trying to get our attention. Bridget, are you there?
Yes, please, Doc, I'm here.
Were you trying to ask something?
Yes, please. Because of the challenge I have with, and I think some of my colleagues have similar challenge, and I don't know if we can proceed, and that will not affect the subsequent ones.
Okay, is it that when you run the initial commands, it's still not working?
Yes, please, Doc. It's still not working.
How do you have the Altera saved on your computer?
Stay, please, as it is. I haven't made any
Altered
amendments.
it.
Yes, please.
Then that's strange. It should work.
Oh,
I didn't get
sorry. Please, is it possible because we are starting afresh, we are not continuing from what we have? Could that be a reason why it's not running?
No, the
so.
Altera data, we've used it severally. And
Yes.
One
It's
thing, so this is it. Betty, I have seen your issue because you sent a screenshot.
yes.
Now,
Yes.
if I look at what you have here, if I look at it, where is the data Altera? You've not loaded the data Altera, have you? So please listen. One of the key
Please, I
things,
have.
so
I
let me
have
see.
it in the environment.
But what I see, I can't see the data loaded. From what you, the snap, can you take a whole snap for me?
Yes, Prof.
Because what I have here, I can't see anything.
Well, please, I've shared mine with you.
Okay, so this is it. Okay, so now let's go systematic. Yes. So in your case, this is what you do. Now, wherever you are having the error, so yours is this. This is where you're having the error. So look at what I'm typing. Can you see my screen?
Yes, please, both. I can.
So if that is what is going to give you problem, just type FT underscore. Maybe I won't use underscore. I'll just make it PT, right? FTPT. Let me just demonstrate because my rand has got factor. Are you okay? Wherever you had a problem that is indicated below, then you just do Altera $. Look for the variable which is causing the problem. If this is the one causing the problem, just click on it. Then when you are done and everything, run it. You won't get the error. So please try it.
Okay, please.
So
both.
for example, I mean, what Betty sent to me is because she's having a problem with the FT. So Betty, use the route I showed you and you'll be fine. And then there's another one. So, okay, the same Betty I sent, Altera Betty. Please, if it works, let me know.
Please, both.
Please, I'm sending another picture.
Let me check.
Hello, Prof.
Yes, please.
Please, where your cursor is it a closed bracket or is
I didn't get you.
please where your cursor is? I want to find out if it's a closed bracket.
No, it's
Where which
opening the bracket rather.
GLM, then the bracket.
yeah, it's apostrophe. How do you call it? This one?
No, say model assigned GLM.
Model what?
So right
Assign what?
after the logistics regression,
Yes, please.
yeah, it's rather opening the brackets.
GL.
Okay.
Yes, I
Yeah,
heard that one.
you can even put it together. I just decided to separate it. Right? I just decided to say you can put it together or you separate it. It doesn't change anything.
Yes, please. Yes, please. Thank you.
Yeah. Is there anybody with just not anybody with an
It
error
didn't
that I
change.
need to know?
No, Prof.
Just a minute, let me move. I've seen why is this thing not loading? Okay, let me just look at what somebody sent. Yes, so you have the PTPF. You see, Betty, please, you don't type. Who is this? Let me see who sent me this. Betty, you will always get an error based on what you sent to me right now. 29, is it 29? Or this has been addressed? Is it new or this is the old one?
Is
Hello?
a new one.
It's a new one.
Yes.
Yeah, but please listen. Whenever you type a command, you don't, that's why I said what you have there is not correct because look at this. This is the case. When you get to Altera here, please look at the bracket here. Once you put the dollar sign, automatically scroll down to select how it's presented here. Not you typing. If you type, you will make a mistake. Right? So don't type, go through it and just click on it. Right? Once you click on it, you have this coming up. Right? So don't, how do you call it? Yeah.
Noted, Prof.
Any question, please, can I move on? So this is, I'm going to send you this. What's happening here? So I've sent you this command as well. Now, Emmanuel, what you sent to me is just telling you that what you type and what is in the data is wrong. So just repeat the same process I did for the last one. Type in Terra recruit is from your recruit site. And it's saying that the recruit that you've typed and the recruit there is not compatible. So to make it compatible, you need to type. To make it compatible, you need to type. So for example, Atera, I want to make it recruit. Let's say I call it recruit. I mean, if this is it, how did I call it? It's called recruit channel, something like this. As dot factor Atera. This time I don't type. I rather look for what is here and select. And then you run. Voila, I don't get an error. So please do same.
Yes, please. Thank you.
Hello, Prof. Hello, Prof.
Any question? Please, the command I sent to you, were you able to run it?
Prof, please, the command is not in the chat.
Is what?
The command you sent is not in the chat.
That the command is?
It's not in the chat.
It's in. The problem is not in the chat.
When I open my chat, it's not here.
Yes, Prof, it's not in the chat.
I think it's there.
Or it went to an individual.
Probably because the last command we had from you is the one that was asking us to make sure categorical variables are factors. That was the command we got from you.
So I've resent it.
Thank you.
I never thought this would take us a long time to. Okay, this thing went off, so yeah, you understood. Please, can we move on?
Yes, please, Prof.
Please, any question? Any question?
Please, Prof. Library into bracket car. I'm trying to type it. I'm not getting the.
Hello? Please, any question?
Hello,
Oh, please.
sir.
Yes, please.
Please, I remember last week you mentioned that if you are doing library into brackets something, we should go to packages and make sure it is run
Okay.
or something. I remember you mentioned. So are we supposed to run that again?
No, you just run it only once. I said that in the that if you don't
So
have it,
those that were not able to run it, should we go to packages?
yes. So go to packages and run it. If you are not able to run it, but even with the library here, once you type in library, if you've never run it before, R will put an indication at the top that this is a new, you see where my mouse is? That's where it will put it. This is a new,
Yes.
if you don't have it, it will give you a signal. Once you begin to run, because I have it, so it doesn't give me the signal.
Okay, so say I've gotten it.
Yeah, so you can click on that signal and it automatically run it. Yes, any question?
Sir, please, sir, if I understand you well, I should click on the library car and then run it.
Try running the library and what do you see?
Yes, please. Error in library car. This is no package call. There is no package call
You
car.
go to library and go and run it.
So, Prof, I should go to
Okay,
Go to library.
package. Yes,
Yes,
sir.
yes, where you have it. Where my mouse is.
Yes, please.
Please, have you been able to do it?
No, Prof. I'm at the package. I can't. There is no car in my
There's no car. You have to type in car. You just type in car. You see it.
Yes, please.
You are
So
package.
probably if I go to package,
Install.
then install. Okay. So I should type car. Yes, please. Okay, I have installed it. Also installed it. Yes, please. A lot of things are running. Yes, please. It's still running. So please, I'm done. It's done running.
So just go to the library. Just as I type it and then run it.
Yes, please. Yes, please. I've gotten it, please. Thank you.
Please, are we all together? And or there's somebody who is having a challenge? Yeah. Okay. Are we all together? Hello.
Hi, Prof. Please, I'm here.
Are we all together? So let's run the
Hello,
library.
Prof.
Yes, please.
When I ran it, it told me data loading required. I don't know if I am.
You ran what and it is telling you data loading.
The library. It's a loading required package. Car data.
Yeah, so go to the, you don't have car there, right? So go to packages, install, just as we have it there. Packages, install.
Okay. Yeah. All right.
Please, were you successful?
Yes, it is loading.
Okay. Please, can we move on, please? Yes, can I move on?
Yes, please.
Okay. Please, can you see my screen, by the way?
Yes, we can.
Yes.
Please, because I'm not able to So the next thing is for us to run what we call the likelihood ratios. Remember, I talked about the likelihood or the maximum likelihood. And this is how you run the test. Don't worry about the interpretation. The first thing we need is to look at the various tests. Time is fast spent, so we won't spend so much time. I won't do a lot of the interpretation. But hopefully next week we can go back, revisit it, and then look at the interpretation, and then from there I'll move on further. But when you run this model, please look at this. When you run this model fit, this particular model, and then you print, you see that if you move this up, and then I manage to drag this, something like this, you have this whole results coming up. But it's a very lengthy result.
Yes, it's very lengthy.
This is a lengthy result you have. But this is not complete because the completion part is the last bit, is the stars which are missing. This one's. So if you have, we have something like this. Let me just go back. Let me rerun it again and see if by opening. Good. By opening my distance, by expanding it, this is how the results quite lengthy, and each one of them has a meaning. Did you all get something like this?
Prof, please, the prompt you used, I didn't get it.
Which prompt?
The one that you used to get this lengthy result.
I put it in the chat.
Okay, Prof.
Please,
Yes,
can
please.
somebody say that? I don't know why my screen is preventing me from, unless I minimize this. Please, I place it in the prompt. Have you all seen it?
Prof, I've seen it, but the likelihood from should that one come before this one?
This should come before the likelihood. If you see my, if you see it, oh, this came before this one.
So, Prof, so we
Because,
are,
yes, please.
I wanted to find out where,
You wanted to,
I wanted to find out where this particular prompt you sent us will put it.
which? Oh, I'm not getting you, unless otherwise.
I'm not
The
seeing where.
prompt that was sent by Prof earlier ended at summary model. So he's
Yes,
yet
so
either you
some,
type it or he sends it to us. So Prof, please do us the honors. Thank you.
so I've sent it. Please, you all have it.
Prof, please, I have it, but I'm putting it close to summary model.
Your line seems to be breaking along the line. I didn't hear you.
Well, please, I said I wanted to find out the prompt we just copied. Are we placing it as where the summary model is?
Place it after the summary model.
Yes, please.
Yes, please.
Hello, sir. Please,
Yes.
I realized that with the RL underscore test, the second one had no underscore.
Yeah, the second one is a command. The first one is the name
Oh,
I'm
okay.
giving.
Okay.
Please, any question? Comment. Comment. Okay. Any comment, question? Comments? Addition, subtraction?
Please, when I ran it, I didn't get what you got. It's not lengthy as yours.
What you got is from this.
Yes.
So you have to run the first model. When you run the first model, that's why you get this lengthy thing. That's the result. Then you run the next model. This one.
Oh, please, I can't see your cursor.
What do you mean?
I can't see your cursor.
My cursor is at run. So
where the cursor was before you went to run? You said I should run the second one.
I said that run from 4438. Put the cursor
Yes.
there and then start run. That is in my case is 438. I don't know about you. So that's
Yes,
where you
please.
start running. When you come here, you run. Run. You have your first result. Keep running for the VIF. You have this. Then you have the log ratios. You have this. So if you open it, you have all this coming. This is the last result you have. Then this, and then this is the long one. Any comments? Addition, subtraction. Any comments, any addition, any subtraction? Comments, addition, subtraction?
Oh, please, when I ran my error, got an error. So I've sent it to them.
Yes, the likelihood ratio, where there's the LR test, it says could not find function.
Have you run the first
It's
model?
an error. It shows
Okay,
error.
Run the
Prof.
model first. Please run the
Prof.
model. If you
Hello,
don't
Prof.
run, You can't run the rest.
Yes,
Hello, Prof.
Prof, please, can you repeat what you said again? Eugene, 1 minute, please.
Please run the
Okay, I'm
model.
speaking to your error.
Oh.
So just run this model. If you don't run this, if you don't run from this place,
Okay.
if you don't run this, you can't, whatever you run, and you come and run this, you get an error. So run this first.
Hello, Prof.
No.
Yes, Prof. So with Betty's error, I also had the same error initially, and I realized that I had not installed the LM test package, so I had to install it and run it before I was able to run
Oh,
the
you don't have the
underscore test.
LM.
Yes,
You
I
don't
don't think most of us don't have it, so I had to install it, able to get the LR test summary.
Mm.
So I think we need to install the LM test.
Mm. Okay.
It should also come with a car package. So if you have the car package,
Mm.
you shouldn't
Okay.
have a problem. So
Yes, so I think it's the version that we are running, the version of R
Okay.
that we are running.
so you either run the car or you run the dply. You should have
Okay.
the results.
Okay.
So
Mm.
please, Prof, from there,
Okay.
I've run the model. I've
Mhm.
gotten the result. So I should go and run the,
Please run the rest.
yes, please. Yes, please. From the car.
Yeah.
I'm still getting error. Likelihood ratio test, comparing model to non-model.
From the car.
Eugene. Okay.
Do you run
One
the
minute.
Yes,
car?
yes, Betty.
Now, please
Yeah.
listen. Please listen. Just pay attention to me. Everybody must have the car model, right? And then you must also run. So I'm going to put in the chat what you should run.
Okay. Eugene,
Yes,
please, with the LRT, and when you are installing it, does it say LRT test and there's a
no,
ER at the end?
My mouse. Oh,
so you
okay.
install LM test, L for
Mhm.
language, M for mother.
So
And
please
then,
copy, Eugene. Let them
yes, sir.
copy whatever I've pasted there.
Okay, sir.
1 minute. Let's see.
Just copy and run it. And you, after running it,
So please, Prof, when we copy it, we should go to package.
no, just copy it, put it in R and run those three things over there.
Yes, please. Yes.
So for example, I mean, before you can, in fact, if I am working, I have a way of putting all my packages at one side, right? So for example, you put it here, you run it from here. When you finish running it, please pay attention here. When you finish running it, you have to load the libraries. All that you have to do is, after running it, you come here and you say library. Right? Then you can do a library for car, another library for LM test. Another library for resource selection. Library. That's how you go about it. When you finish running it, you don't need to keep this active. So all that you do is, after running everything, put the hashtag there so that it will become inactive. Because this must be run only once. But it doesn't hurt if you run it several times. That one is a choice, but I always say that you should run it only once. Any question? Any question, please?
No, please.
Okay. Okay. So today hasn't been the best of days, but let's see how it goes. The machine messed me up on the line. But so far so good. We've been able to look at the LN test. What we want to do is later pick each of them. I would copy the results into the slides. Don't know whether I even lost it. I'll save it. Let's see. Let's see how it goes. And then I will share it. And then the other thing is we would put let me see. We'll put everything together for you so that you can also have it. And then you can also be revising on it. Please, any question so far? Please, any question?
Hello. Hello.
Hello.
Yes. So after writing, wondering
Pardon me?
yes, can you hear me please?
Yes, I can hear you now.
Yeah. So after running everything, wondering what is the likelihood ratio test used
After running?
after running everything and getting the figures that we got. I was just wondering, so what is the line ratio test used for? Because I realized you were comparing two models. So I'm confused.
So in the model, the question is you have the actual model and then the estimated model. Is it okay? It's like this. When you are even testing a hypothesis, you have a null hypothesis and alternative hypothesis. So what the likelihood does is that it compares the two to find out Is there any significant difference? Is it okay?
Yes.
Yes, please. So that's why it is comparing the actuals against the estimated.
Okay.
Mhm. And then what did you find?
So I realized that no matter what happens, the likelihood that the person is going to get one award is high.
Only is it my machine which is now developing a fault or he said you realized that was Eugene.
So after everything, I realized that awards one was one, even with model 1 and model 2, it was still giving me 1. Yes, so it means that no matter what happens, that person that we are running the thing for is likely to at the end of the day.
I didn't get you. No
That's
matter
how
what
no matter what happens, the person is going to get at least 1 award. That's what I know about it.
When
I'm
you get
correct.
to let me see the results. Right? So if you look at this result, what can you see? You always have to look at the p-value. Is it significant or not significant? I wanted to reserve the interpretation for next week, but once you've started, let's move on. Is it significant or not significant? That's the first thing you have to ask yourself. Yep. So Eugene.
Look.
Yes, are you with me?
Yes, I'm with you.
Question. It's not like it's not for you to answer the question.
Yes, I'm with you, but
so the first question you should ask yourself is, this model that I have run, is it significant or not significant?
Okay.
And if it is significant, what does it mean? So if you are not able to tell whether it is significant or not, you can't move a step, right? So let's start. Is the model that you run significant or not?
Significant.
How did you know it's significant? How did you know it's significant?
Because it's way less than 0.05.
Okay. Now, so let's start here. So remember, here we have the estimated model against the actual model. Now, I will also go into the model and want to find out if I equate everything, if I do a reduced form against the full model, will it be statistically significant or not? If you're, yes, please hold on for me. Noah, I'll see you. Yes, sir. Thanks. So if you get your result and it is significant, what is telling you is that there's a significant difference between the now model and the alternative model. And it means that by adding some other extra variable to it, this will lead to an improvement of the general model. So, I mean, that is just basically the interpretation. What does that mean in real terms? In real terms, all that we are saying is that if I have a simplified model with award 1, and then a model which has education, I didn't want to explain this, but let me explain it. If I have, this is a full model, right? This is a full model. All this adds up to my general model. Then you have, if you look at the test, let me come here. This is model 1, and it's a full model. Then you have model 2, which is a reduced form of the model. So if I compare model 1 and model 2, so model 1 is generally the full model. There's the model that you have. Then model 2 is just the estimated model. So you are finding out, is there a significant difference between these two models? If you run and your answer is showing that there is a significant difference, just as we found here, what does that mean? It means that as we add all these variables to the model, there is an improvement. It also presupposes that we've captured most of the variables that we need to capture within our model framework. I don't know if you have explained it to your understanding.
Prof, please, can you go over it one more time? Thank you.
All that I'm saying is that, you see, this is the full model. This is the actual model you have estimated, right? So this is the model you have. That is what we call model 1 here. Is that okay with everybody?
Yes, sir.
Yes, Prof.
Yes, please.
Then you are going to compare this with your estimated model. And this estimated model is just a simplified or a reduced form of the whole full model, which the system generates. We can also set up the model if we want, but we won't set it up, but the system has generated it. So you are supposed to compare the results here, model 1 and model 2. That's what the likelihood is all going to tell you. And when you do the comparison and you run the statistical test and you find out that it is significant, just as we have here, highly significant because almost equal to 0. What does that mean? That is just telling you that the full model or the actual model that we have here is better. Why? Because it accounts for most of the variables that we need in order for it to say that, or it accounts for factors that actually influence the person winning the award. So that is why it is saying that if you get a significant result, it means it is better. So the estimated model is better than the model put out or the reduced form of the model. Just say it that way. Simply put, if I put all of you together in a class and then I say, okay, I want to find out whether if there's a competition, the class will win against just selecting one person to participate on behalf of the class. You realize that if you put all of you together, we stand a better chance of winning than one person going for the competition. That's all that the model is saying. Is it okay?
Yes, Prof.
Eugene, any
Yes.
question? It's Eugene who
Yes.
has brought us this far because I didn't want to talk about it until next week.
Yes, very much. I have gotten it. So I just wanted us to make meaning out of what we're seeing.
Yeah, but Eugene, you have made me explain what I don't want to explain because I wanted to leave it out and then we'll explain next week because next week we have to pick this whole equation, this long model, and explain all this long model.
Okay, but at least.
And how to interpret because these are the odd lots. And we have to take our time and interpret.
Okay, sir.
So please just take it as one of those. And then next week, God willing, if you are still alive and healthy and strong, we'll come back and we'll try and interpret all this long regression that we have here.
Noted, Prof.
Any other? Okay, so if there's none, Doc, please, I want to,